So thank you for everyone for actually joining this and participating, which will make it a lot more fun. So introductions, I don't think we should go around the room and introduce ourselves. Maybe if we start speaking, we could do that, but everybody join the room. So here are some topics that we have, but I think we are most excited to go in whatever direction you're most excited to talk about. So I will rush through some of these and then I'll come back to this slide and we could pick in random order, so to speak. So a new measure of responsiveness. We've been pushing more press publicly about this, but this has been a long time coming with a lot of work with our partners in the web performance working group. And it's grown out of a bunch of efforts in event timing. And so we're pretty excited just because of how much uptake this has had in the last several months. So what is this? We are targeting to create a new core web vital in the long run that will replace first input delay. And so for that reason, it has to have all the properties that core web vitals have, but it is not yet a core web vital. There's plenty of work left. So it's kind of an experimental new metric that we're shipping, but we're quite happy with a lot of its features so far. It's meant to measure discrete user interactions. So things like tapping on a touch device, typing on a keyboard, or clicking a mouse. And not continuous events like scrolling, stylus, hover, that sort of thing. Based on event timing, and similar to a lot of metrics that we have internally, like event latency, it's measuring the end-to-end time, or I shouldn't use that for statement, but it's measuring the time from when an input arrives from hardware to when pixels are actually presented to screen. So it's the full time span before there is some feedback, some visual feedback or otherwise, to that interaction. And to help developers sort of wrap their head around all of the parts that go into this, we've sort of broken it down. We typically describe it into 3 parts. There's input delay, which is anything that gets in the way of event handlers running. This has been the focus of first input delay as a core vital for a long time. Then you have the processing time of all the actual handlers that are dispatched for that event. And then finally, there's all the work that comes afterwards. And some of this time is easy to measure, and some of this time is harder to measure. This last part, the presentation delay in particular, is sometimes magic to a lot of developers. And so this is a lot of education, awareness, tooling support. And I think we've ourselves, even the experts, been surprised with what we found the more we focused on this. So we might come back to this, but just throwing that out there. That's typically how we describe it, but there's a lot that goes into that last part in particular. The name of the new metric is Interaction to Next Paint, or INP for short, and there's a blog post about it that goes into a little bit more detail. And maybe the first thing we could do is just have a little bit of fun playing with it. So I have a few slides, and then we'll switch to a demo, and then we could talk. So I mentioned that it's built on top of event timing. This is not a new API, but it has continued to evolve, and we are continuing to improve it. So there's a link in the bottom corner here where you could get from the blog post the snippet. This is just a screenshot, so it's harder to copy. But and there's support for Firefox, except for one tiny little feature where there's a comment that says uncomment this if you're on Firefox, which is amazing. Yeah, I won't go over all the details. There's also support, and we have a Web Vitals JS library, which makes it much easier for developers to sort of import this and measure it. So it's kind of a reference implementation, but a lot of folks are using this directly, but also a lot of RUM, performance measurement tooling that a lot of websites use kind of look to this as a reference implementation, and they go from there. So it's still on sort of a next branch, but it's making its way through. The metric is also being picked up by a bunch of tooling downstream. So we added, Chrome has in UKM been measuring this for several months now. We've sort of iterated over it. We've exposed the values to Chrome User Experience Report, which is our way of sharing publicly the field data metrics that we measure for Chrome users. And so since Crux provides this report, tooling like PageSpeed Insights and HTTP Archive and Web Page Test and a bunch of other downstream things are beginning to show scores. So a lot of developers will go to PageSpeed Insights as a way to throw a URL and just get a report. You'll get something like a Lighthouse lab-based analysis with a bunch of audits, and you'll see that at the bottom, diagnosing performance issues. That's like a lab run. But then at the top, you'll get your real field data results, which come from real users. And so in the bottom middle there, there's that new metric that compares to the other stuff. And it kind of sticks out like a sore thumb on many runs where you'll have a lot of pages, a lot of developers are giving us feedback saying, oh, wow, like we're doing so well on everything and this thing's really red. Like we weren't even aware of the problem, which is kind of the point. That is one detail that Core Web Vitals have, is that they draw a lot of attention and awareness to these things before we can actually go and fix them. There's a Web Vitals extension, which helps you measure locally. We might talk about this a bit later, but if anybody has not installed this yet and you just want to get a sense for it, you could do that. The extension kind of helps you do some debugging. So if you're accustomed to using performance profiling through DevTools, there aren't too many features for debugging interactions. There's kind of a long history there. We used to have some features here. We kind of broke them by accident. We fixed them, but they weren't working exactly the way we wanted it. So we decided, instead of adding something that isn't quite right, we'll wait to ship a perfect version in the long run. So tooling changes are coming. In the meantime, we have support for dropping user timings. And basically, as you're recording a website, if it drops its own timings, DevTools will visualize them. And so the extension is playing that role. It's dropping the interaction timings. And so if you're doing a recording and you have the extension installed, you'll see them in the timings track. Anyway, it just helps debug. It helps developers find the source of the problem before they dig further. All right, and there's this fancy website which we published. The top one is kind of the formal one. I hacked together the bottom one, just to make sure it works in Firefox and Safari. And if anybody wants to try it locally, it helps you manipulate how much delay you want to introduce artificially and just get a sense for how bad does it feel. And it, you could sort of tune your expectations. When do you start noticing interaction things? I'm going to switch what I'm demoing and I'll show you something interesting. But as I'm doing all that, play yourselves. All right, let me see. All right, there we go. I'm assuming you folks can see this. So this is Firefox. Here we have Chrome. All right, it's a little bit slow because when I'm casting, it's a little bit slow. So what this page is doing is it's measuring using event timing to give you your INP score. Your INP score is, in its most simplified form, what was the worst interaction problem the user saw on this particular page load? And with this test page, you can add a bunch of delays. So you can add pointer delays, you can add key delays. So if I start typing, I added a bunch of artificial delays to this page and it felt kind of really janky. And I get the score, which is in milliseconds of how long it took. And so I can adjust the timer values, and as I interact, I could feel the amount of delay there. And I get a nice little table displayed. Here's something that I wanted to show, which leads into a conversation. There are differences across the different browsers in how we handle input that affects overall responsiveness. Okay, Scott's on the room. He might know what I'm going to show. If I throw a bunch of slow key events at Chrome, so I'm going to one of these, swiped on my keyboard a bunch of times. Each keyboard event is adding just a tiny bit of delay, but nothing updates. There's no visual update. We don't produce any new main thread update. We don't commit until all of those keyboard events are done processing. So you end up with like a 5.5 second delay here, even though each key is only taking about 100 milliseconds. So each key would be, not great, but within a reasonable thing. If I type one at a time, it's not so bad. If I switch to Firefox, is this Firefox? That's Safari. And I refresh this page. Okay. I do the same demo. Firefox makes some different decisions. It's kind of janky with VC, but it doesn't block all painting. It instead processes some number of key events paints, and you get a progression. So it is pretty janky. The frame rate drops. You don't see all of your output right away, but you get a steady stream of updates. It's just a difference in scheduling, but it makes a big overall difference, at least in the initial input. And so this is, as we measure, we found these types of differences, and we ended up finding real reports from products like Chat and Docs that they've been suffering with this issue for years, and it's kind of gone unnoticed. And now that we're drawing attention to it, we're finding it. I don't know, Scott's working on a fix for it. I don't know if you want to unmute yourself, Scott, and share anything there.
Yeah, this is just like kind of an artifact of how we schedule rendering. We prioritize input, but not necessarily rendering. These would run sequentially, and then we block painting for a long time. So I have an experiment out now that prioritizes the next paint after an input event, after a discrete input event specifically. We tried this before with continuous inputs like scrolling to try to improve jank there, but we found that heavy rendering would actually degrade performance to a point where we couldn't ship that. But focusing on discrete inputs, we're hopeful will help here.
Absolutely. Thanks, Scott.
This data, I wouldn't read in too much of this. This is Canary dev data. I don't like to draw too many conclusions from that, but overall, we've seen a lot of statistically significant improvement so far just in that data. So we're excited that this could have a real effect.
Yeah, absolutely. So my main takeaway, other than this will be super cool to fix, because when it doesn't bite you always, but when it bites you hard. Rick talks about LCP and how, Rick talks about LCP and how when we shipped it as a Core Web Vital, he was convinced that there was no more work to do or no more progress to be made through changes to to Blink and to Renderer. Like we had optimized things as much as possible. And that the remaining wins would have to come from ecosystem. It comes out that that was partially true. There were lots of wins that came from ecosystem, but by drawing attention to it, even across the organization, we ended up with lots of wins internally. It threw more emphasis on shipping features like BF Cache. We had priority hints. We ended up doing a bunch of the Swarm projects, like huge wins across the org. And so LCP improved in ways that we, for years, thought was not possible. And I think responsiveness, same thing. It's not rocket science necessarily to measure interactions this way, but just drawing this amount of focus on it has already yielded value, and I think we'll continue to do so. So anyway, it's just, we're all very excited about it right now because we see how like low-hanging fruit in some places and lots of potential. Maybe I will switch to the first slide to see what we want to talk about next, and interrupt me at any time.
So I guess the risk with doing that kind of change is that like you might be rendering something that just needs to be changed based on the subsequently queued events that you haven't run the event handlers for yet. And so you could increase the total latency for all of the in-flight input to be processed. But
so one thing I do want to point out that I recently learned is that the event queue will iterate over all of the queued input it has so far, and we're not interrupting that flow. So we would, if it's a new incoming event, like we're just trying to paint what the input queue has just processed. I think new incoming events, we wouldn't run before the rendering, but we didn't change how the event queue iterates over what it has already.
oh, I see. That's interesting. That didn't.
So like what we found, like what could happen also is like that if that paint was queued like it just in our renderer as normal priority, you could get other things in the way as well. So not even just a next input that's coming in. Like that is one case where like fast typing could be a problem, but also just other craft kind of gets in the way, like timers and so on.
Yeah, I think there's plenty of opportunity to continue iterating on those heuristics. I've seen so many ideas already. Does anybody have a preference of which one of these to tackle next? I see a bunch of folks in the room who are.
SPA.
All right. Gnome with the hard hitters. So SPA meaning single page applications. So here's a quick screenshot of a classic client-side only SPA. This happens to be the reactjs.org website. Notice that there is a long blocking task before load, before LCP. That is when the page goes from blank, basically, to booting itself up with JavaScript, creating a shadow DOM, and then updating the actual DOM, and then you get visual components that are interactive. I am unable, when I load a site like this, I am not effectively able to interact with the page. There's no interactive content. There's nothing incentivizing me to attempt interactions. So in this case, everything about the site is very fast afterwards. It's well designed. It's pretty buttery smooth. Okay, so there's some amount of concern about what happens with SPAs and stuff like that. But like a classic JS-driven site has, loading issues and then is pretty interactive afterwards. And so there's not much significant concern on this metric specifically. I just wanted to point that out, that thing. On the other hand, let me see, am I switching? This is an example of a site that does a tactic called server-side rendering. It's also React-based. It's the Next.js example. So for anyone who's not aware, server-side rendering is you basically run your client application in a headless browser or however you do it on the server, take a snapshot of the content of the page when it's loaded, serialize that and ship it to the browser. So you get the first view much sooner. You don't just ship JavaScript and build everything client-side. You ship actual HTML, DOM, CSS with the first view. But then you rerun all that work client-side, and you have to basically delta to make sure that you can sort of bootstrap all of that client-side effort. And that process is called hydration. So in this case, I had, the page was visible. It looked interactive to me much earlier, but then there was this long blocking task as it was hydrating. Now I was slowing down in order to get the point across. So this isn't actually this slow. If you open this pipe, this is simulated slowdown on CPU. But if I interact during that process, everything looks completely unresponsive. There's no visual update whatsoever. And so you get these crazy high interactivity scores. This is a real problem on many single page, or like many of these types of sites that use these frameworks, which typically are used to build single page apps. So in this case, that 1 second hydration turned into like 4 seconds because I'm now trying to interact with the page wildly at the worst moment possible. So this is a real SPA problem that was not always affecting first input delay. And on these traces, when I recorded them, hydration is a single blocking script, but these frameworks tend to use more intelligent tactics. For example, either checking is input pending or just chunking up the work and yielding every 50 milliseconds. It's still the same amount of work. They still have all of this JavaScript that has to run, but instead of a single blocking task, they will sometimes chunk it up. Like if you enable all of the features in concurrent mode and actually ship a real production site, it's very common that that's what happens. So you won't have input delay, but it'll still have to do all of that JavaScript before it can handle the event. So that's a big problem that INP finally measures, where FID did not always measure it. In this case, on this trace, it did, but on most public sites that we see, it wasn't. So first input delay tended to do fairly well, where INP does not. So that is just one quick thing that we are excited about finally being able to address. Go ahead. Is that Patrick?
Yeah, do we have an opinion on the trade-offs between INP and LCP in these cases, or for sites that aren't really SPAs but are using SPA frameworks, are we telling them don't and just ship static HTML? Because, I mean, at this point, if you have an SPA framework and you are doing hydration, it's going to be a trade-off. Do I either make my content slower to paint, or do I make it interactive sooner? Unless they completely gut it.
So that isn't a fundamental trade-off. I agree that out of the box today, the popular options that is, but all the rage, all the hotness in the JavaScript framework space is to have your cake and eat it too. I don't know how much everybody in the room follows that, but the current status is we had developed these frameworks that were optimized for client-side components and building the whole app shell entirely locally. And then we just started rendering in the server and doing all the work twice, full end-to-end. But now the new direction is if we're heavily leaning towards server-side rendering because of the benefits to LCP, because of the benefits to SEO, because of the benefits to accessibility and etc. Well, you really want a server-side rendering aware framework that does that. And so with React Server Components and some of the more modern frameworks, that's the direction. And so if you start with an actual server that knows how to render components, you can have a smarter hydration. So React has taken, I think, very good incremental steps forward where they just chunk up the work into bite-sized pieces. You know, some folks call this islands. Like instead of having a whole app shell that all of it needs to boot and finish hydrating all at once, you'll have tiny little chunks and you'll prioritize the chunk that is needed to interact with whatever you're interacting with. So instead of having a 1 second blocking task, you might have 100 milliseconds, 10 of them. You know, other frameworks are trying to lazily do as much as possible, or like hyper prioritize the specific thing you're interacting with in the last moment. So there's a lot of effort here. So I think there's no need to have a preference or an opinion. I think that we should just wait and see what happens. I do think that using this new metric for interactivity will help make those types of trade-offs and balance them, which has always been, I think, the goal of Core Vitals, where the three of them can sometimes be, you know, a scale, a tipping scale, and you want to keep it nicely balanced.
Yeah, I mean, I think it'll definitely push the frameworks to do better as far as server-side rendering and not require running it all twice and all of that kind of stuff. It's going to be a bumpy year, I guess, or more is probably the best way to put it.
I don't have recorded traces, but the other direction is also happening where folks are optimizing for less work during load, so no long tasks. But then you have like a persistent cost to every interaction after page is loaded. Like this type of flow is optimizing for LCP and for long-term interactivity once everything's booted. And it's got this like spike of crud in the middle, and we're trying to amortize that cost. But other frameworks are optimizing in the other direction where like everything is super lazy last minute. And so every interaction has like a fixed overhead. And so I think INP also helps with that potentially. But it's, you know, it's a new world. All right. I think Gnome was probably hoping to talk about some of these other effects, which are more nuanced. So first, the good. INP measures real interactions and measures them end-to-end in ways that we are quite happy with. It's not some artificial score. You know, we've had some issues with like the original version of CLS where it would just grow over time and so thing. But this metric measures the whole page lifecycle, but doesn't arbitrarily grow over time. If you find a responsive single page app, it will score well. It is not unachievable. It is measuring real things, and you can hit these targets, and they're lenient enough that you should be able to do that in a well-designed site. It's a little bit more complicated as to how we feel about this middle part. So route transitions right now on a single page app are measured as interactions. So the whole point of building a single page application is that you can replace some hard page loads with JavaScript that renders in place. And so it's replacing loads with interactions. We measure those as interactions. And so our thresholds for the expected responsiveness is measured the way we measure all interactions. But I think that it's gray area here. Like sometimes these things feel like loads where the whole page is refreshing. And so maybe the user is okay with measuring that delay in seconds instead of milliseconds, so to speak. But it depends it depends on the site and exactly what's what the transition is. And there are things SPAs can do that to break out of this, basically, to still unblock the first paint, do the rest of the work afterwards. And they, we've met with these framework authors and they agree. This is the advice they give developers already. The other thing that's complicated is the longer you spend on a page, INP is looking for that worst interaction. With caveats, it's not actually worst, it's P98. But if you spend a very short amount of time and interact a very few amount of times, you might have just gotten lucky. We might not have found a poor interaction on a site that tends to be not very interactive. Whereas on a site like an SPA, if you spend an excessive amount of time, we will sort of find that peak and plateau. And so you tend to reach that peak and plateau more consistently on a site that you spend more time on. And so it's not like we're measuring wrong necessarily. It's just that we are getting, we're finding that value more consistently. And so again, it's complicated. This is, I think, a good thing, but it is true that SPAs tend to not benefit from these really low INP scores. And then all of our vitals have some of these concerns, which are not so good, which is we currently measure the whole page load, but we don't include document navigation. So we don't include routes. So if you have an SPA where you have multiple route transitions, it might logically feel like different views to the user, similar to different URLs, but we will report that as a single page load. And so, you can have something really poorly perform halfway through your session, and we will attribute it to the top level URL that you started with. And this is true for all of our vitals. So there's a bunch of projects in this area to improve on that situation. It's not specific to INP, but it does, in some sense, still affect INP. And then also, SPAs just tend to have fewer page loads. And so, your overall histogram data is still somewhat equivalent. Like you should still have these performance targets per session. But in combination with the stuff that I mentioned earlier, like less time on page, plateaus less often, the fact that there are fewer page loads, fewer reports, it compounds. These two things bounce off each other. But again, we have some projects in this area that we're working on to try and address this. But we're out of time. Gnome, how is that?
Yeah, it's really great. I have another general question if we have time.
I'm going to stay as long as we need.
Okay. Is it possible to share statistic analysis of the stability of the metric across different origins? For example, does it have like high variance and can easily be used for detection regression for the app? Because we found that it can be challenging to find a metric and decide on how to aggregate it. Like you can take the score and average it over time, or P95 or any other sort of aggregation. Do you have any thoughts around that?
First, just do you want to compare different origins or like one origin score rather than?
Well, for me, it's one origin.
Okay.
I would think app developers interested in their app, assuming it's in a single origin, and want to track the improvement or regression over time.
Yeah, I mean, you can record your own measurements through the strategies I mentioned earlier, like the Wild Vitals JS library or the like event timing. And so you folks, I'm pretty sure, are doing that. And so I have no specific suggestions on how to measure. I don't know if anybody else in the room does. Beyond, like, we typically just do the P75 across all reported. With Crux, what we expose is the full histogram, and so you can look at the full distribution. We tend to summarize that down to that P75 point, but you could do more in terms of analyzing variance and other metrics.
Yeah, I mean, we're looking for a metric that is also not too noisy, right? Because the assumption is that if the application doesn't change, then the score shouldn't change by much.
So you're saying, okay, I see.
If someone introduces a regression, like doing long blocking tasks that interfere with interaction, I would expect the score to change consistently and reliably. And I wonder if you had collected some information on these aspects.
No, I don't have a simple answer for you. But I understand your question better now, I think, which is like, is this metric stable over time? Which comes down to two things, I think, which is are user behaviors stable enough over time that whatever responsiveness is it consistently measured? And then I think separate from that is, are we measuring it consistently? Yeah, I don't have an answer. I'll follow up. It's a good one. With enough data, hopefully the user experience is consistent enough, but who knows? If folks are sticking around.
I actually have a question.
Sure.
So you talk about that. So you're using the 98th percentile to as the over the duration of the let's say the browsing, as long as you stay on the page load to measure.
Yes.
So I did some work on the small sample bias for the 75th percentile, but I assume that it will apply to the 98th percentile too. So this is actually I mean, as far as I can see, this metric could be very biased towards like what the origin or websites that people stay.
So let me just clarify the P98. What we measure every interaction, and then when the page is unloaded, we summarize the score for that page. And so it's at that point that we take the P98 of the interactions on that page. So if you have fewer than 50 interactions, we just take the worst one. But as you interact more and more, say you have hundreds of interactions, you've been on the site for a while, you've been typing for a lot, we kind of drop a few outliers. But you still only get one report for that one page load. And then for each user of each page load, when we have the whole histogram of samples coming from field, we still use P75. So it's the same measurement as all the other vitals. So the P98 isn't overall all field data. That's just a single sample. And it's just basically its goal is to drop a few outliers that are on the high end if you stay on a site for very long.
So on average, like how many pages how many interactions do you see on an average page load?
Less than 10. I forgot the exact average, but like I forgot, maybe it was 2%. I forgot how many have more than 50 interactions. Or maybe it was like even an order less than that. I can't remember. So very, very few sites. But when they do, when you have a site that begins to have like a spike in the number of interactions, it could grow arbitrarily long. You know, again, imagine a chat app or a docs app or, you know, many others where users just tend to have very dense number of interactions.
To follow up on that, Michael, are we tracking that through UKM or UMA to say the number of interactions on a page? Cool. That sounds like a great aggregate stat to make decisions on.
We are, and further, there is a UMA that Annie added. Like we already have a bunch of event latency data, but there's a UMA Annie's adding to measure in the same way that we measure INP, the same criteria, which are subtly different than some of the other metrics. So we get a full histogram distribution of all of those. So we'll be able to do even more analysis.
And all of that feeds into the decision to still measure the 98 percentile because we feel that's a good representation of it, right?
Absolutely. Yeah. Yeah. I mean, really, we were relatively satisfied with using the single worst, but we were worried about this, like spend too long on a page and you'll measure, you know, happen to be GC at that moment and you happen to alt tab and you happen to whatever it was. And so it's not, you know, if a user truly spent an hour on a site interacting 1,000 times, they might love that site. And it might have only had a few very short, like slow interactions. Most of them were pretty good. So we didn't want to hyper focus on the worst case in those situations. And that leads into this conversation, the 100 millisecond rail versus 200 millisecond INP, where we get lots of questions as well. So our guideline for INP is 200 milliseconds. Under 200 milliseconds is good. And that measures at the P75 of all field data, which means a quarter of users could have worse than 200 milliseconds. And that is surprising to many folks because the guidelines we have for Rail for interactivity or for responsiveness is 100 milliseconds. Every interaction should be under 100 milliseconds. And then, you know, depending on which literature you read, it could even be more aggressive than that. And it really is because we're measuring all of the distribution, a histogram of interactions, and we're taking the top end, you know, really right at the very top. And so it's not to say most interactions should be 100 milliseconds. It's to say nothing can ever be above 200. That's kind of the way we're measuring it. And then the other parts are, you know, we have to deal with the reality of the devices that we have and the sites that are out there. And so what's achievable? This is already a fairly aggressive target. A lot of sites aren't currently meeting this criteria. We hope that through platform improvements, framework improvements, there will be a quick like ramp up of improvements here as we draw attention to this. And so then we'll reevaluate those numbers at that point. But does that make sense? You know, the gut reaction we often get is 200, that's way too high. It's so slow. But then when you measure sites that feel fast and look at the actual INP scores, it's like, oh yeah, actually, that makes a lot more sense. You're measuring way more of the pipeline than we've ever really exposed historically. Yeah.
If I could just follow up, Tim was asking a follow-up question on one of the questions I put in the chat. I'm imagining this from a user perspective of, does the user notice the difference between 70 and 60 milliseconds in this kind of thing? And at some point, it just doesn't matter, but sometimes it really, really does. And part of the reality is the user hits a key and they see pixels glow on screen. And the current INP, I think, doesn't capture whatever the OS does in terms of capturing that input, which is usually really, really fast, but it also doesn't capture how long it takes those phosphors to start glowing, because typically that's, you know, hardware dependent and things like that. I just wanted to confirm that, like, IDNP is kind of focusing on that part that the developer could focus on, but ignoring that, how's it really affecting the user from a, like in an imaginary world where some game might really, really optimize and predict on when that pixel is going to start glowing on the screen. We don't have any way for them to see that right now. Is that correct?
Well, we're building on the work that all of us have invested in terms of getting the most accurate presentation feedback of when pixels do appear on screen. And this varies platform to platform. So no, we're not measuring how long it takes LEDs to heat up, you know, or whatever. But we are measuring the driver supported best estimate of time of when the VSync happened based on what's available on the platform. So this isn't measuring like the end of some arbitrary rendering stage. It is, we're trying to measure when pixels are to the best effort we can. And same with the input hardware timestamp. You know, there are differences in the accuracy of those metrics, but it, to the best that we can measure on the platform that we're measuring it, it is the hardware timestamp of the input.
Yeah, and sorry, just I'm not suggesting that it be that.
Yeah.
I think that what we're measuring is the thing that is actionable to a web developer, and that's exactly what we should be measuring. I'm just curious to know if there's any thoughts about those two tangential periods.
So we're measuring things that are actionable and things that are outside of the control. Like we want to represent what the user experienced. And if a user is using a low-end device on a low-end network, with a device that shares GPU memory with CPU memory. Like, the reality is it will take, perhaps 100 milliseconds, fixed amount of time to get input to dispatch and then to get pixels to screen. And so then the developer has a smaller budget in terms of what they are allowed to try and accomplish. But, a lot of Chrome rendering stack is affected by what the developer does. They might have done it several frames ago to overload it, whether it's running JavaScript tasks that block through input delay, whether it's running JavaScript directly, or whether it's doing a lot of DOM updates and then adding an image that takes forever to decode. And all of these things is part of the magic that developers are kind of not aware. And same with these frameworks. Like, you'll do something in a framework where you apply a big render update. Maybe the JavaScript didn't take that long to run, but then it applied this huge delta to the DOM, which then had a bunch of follow-on effects that took forever. So we are measuring all of that. And some developers do say, like, my work was done. Well, but not really. So there are strategies you can use. You can chunk it up into pieces. So I think a very common direction now is to say, what is the most critical feedback to deliver? There's an example here, which goes over like sync and async feedback. So this is an example where you have a text box that you're typing into and you have a drop down that auto completes. And there are two different ways to build this type of component. One way is every time a new key is clicked, you provide no visual update until all of the autocomplete suggestions are available, potentially waiting for a network response, which is not a very responsive demo. The other way is to make sure never to block the input, always display the text update, and then afterwards update the autocomplete. And the user, like the users, from my own experience, even with like search, you don't notice a little bit more delay on that autocomplete dropdown. And so we're not measuring that second part. You really do want to break it down. You want to make sure you unblock that first paint by not doing too much, and then follow up with that additional update. And when we ask, we tend to get shaking heads and nodding agreement. The other example commonly is like input boxes, checkboxes, buttons. Even if you do nothing inside the handler and do follow-on work that's heavy, the button will appear clicked, the checkbox will appear checked. Things will get focused, accessibility features can fire. So not blocking next paint, even if you have to move some of the heavier work to later, it tends to be good for responsiveness. It could be taken too far, but yeah.
I have one question.
Sure.
So lately, by the way, the responsiveness of the mute button is really bad. So lately, I read a few researches about the fact that a user might expect a different responsiveness by the type of interaction that he made, whether it was click or key down, and I was wondering is there any consideration to slice the INP metric by interaction types?
So that was our first. So if you're measuring yourself, you absolutely can do this. We build on top of event timing. And so if that's important to you to measure for your users, you can do whatever, at the end of the day, this is just an incentive to help developers do what's right for users. Our first version of INP did have this idea of budgets, where maybe every type of interaction has a different expectation. And we had 100 milliseconds for tap and 50 for keyboard, which we got from some UX research. This was not a very popular proposal, because it's just layering budgets on top of budgets. Like the whole metric has a budget, it's measured at different things. And so I think a lot of it was complexity. The second part is we learned that there were differences that we weren't necessarily expecting. Like the lines can get blurred between, it's too easy to say a mouse will have a certain property in terms of the end-to-end time and a keyboard will have a certain property. When you have a virtual keyboard on a mobile device, is it touch or is it key? If you have a trackpad on desktop, is it touch or is it physical mouse? And so there were all these weird effects where like having separate budgets didn't make as much sense. So I don't know. I do think it's a good point, but it's surprisingly consistent. And also the differences are maybe not as great as we previously thought. Also, the way we did some of the UX research ourselves that led us to believe different budgets were important. We found out that like sometimes we were double counting some things, and when we cleaned it up, that delta got smaller and smaller. Yeah, I don't know if that's satisfying, but
Yeah, thank you.
all right. I just checked. Hopin, this session has 912 milliseconds of interaction to next paint. I don't know if I pressed the mute button, but yes, I agree with you. All right, I think we covered most topics and are quite over. I very much appreciate everyone joining the conversation and actually engaging. This is much more fun. Thank you very much, folks. Should probably call it.
Thanks a lot.
Have a good one.
Thank you.